So we need to use the definition of a Taylor series to find the first four non-zero terms of the Taylor series for the given function centered at A, and we also need to write the power series using summation notation. So first let's look at the derivatives of f of x. So in our case, f of x equals cosine of x. Then f prime of x equals negative sine of x. Then the second order derivative of f of x equals negative cosine of x. The third order derivative of f of x equals sine of x. The fourth order derivative of f of x equals cosine of x. The fifth order derivative of f of x equals negative sine of x. And the sixth order derivative of f of x equals negative cosine of x. Well, now let's find the values of these derivatives at x equals a. So f of pi equals negative 1. F prime of pi equals 0. The second order derivative of f of pi equals 1. The third order derivative of f of pi equals 0. The fourth order derivative of f of pi equals negative 1. The fifth order derivative of f of pi equals 0. And the sixth order derivative of f of pi equals 1. Now we will use this to write our Taylor series. So Taylor series centered at a equals b is computed as follows. So f of x equals f of pi plus f prime of pi times x plus the second order derivative of f of pi times x squared over 2 factorial plus the third order derivative of f of pi times x cubed over 3 factorial and so on. So in our case we get that f of x equals negative 1 plus 0 plus 1 over 2 factorial multiplied by x minus pi squared plus 0 plus negative 1 over 4 multiplied by x minus pi to the fourth power plus 0 plus 1 over 6 factorial times x minus pi to the sixth power and so on. Then this equals, let's simplify it, negative 1 plus 1 over 2 times x minus pi squared plus minus 1 over 24 times x minus pi to the fourth power plus 1 over 720 times x minus pi to the sixth power and so on. So from this we see that the first four non-zero terms of the Taylor series centered at a are negative 1 over 2 times x minus pi squared, negative 1 over 24 times x minus pi to the fourth power, and 1 over 720 times x minus pi to the sixth power. Well, now let's try to represent it with a summation notation. This equals, so f of x equals sum from k equals 0 to infinity of negative 1 to the power of k plus 1 over 2k factorial times x minus pi to the power of 2